Hi everyone, my name is Vose. So we with our lectures. Last time we ended up getting vectors, resolving them into components. So what we'll be doing now is we'll just be adding vectors in different directions. So we'll start by adding 2 vectors and then we'll go and add 3 vectors. If you're new to the channel, please subscribe. It will help us a lot, and then you can like the video. So if you like the video, and then you can also leave your comments below, so that at least we know how we can actually improve the channel. Otherwise, let's just get into it. So we'll be adding vectors. So you could be getting these vectors in a statement, or sometimes they'll be just thrown for you, like the way I'm doing now. So in these problems, because I'm just showing you what to do, is fine, I'll just throw them. So let me just say I have a vector A. Now, remember, when I don't put any arrow on top, I'm saying that the magnitude of this vector, let's say it's 45. Let's say it's Newton, which is for force. I know we haven't got, we're not on forces, but then some of you may be familiar already. Let's just say the angle here is something like 55 degrees. Now, let's just say I have another vector. So now I'm adding vectors that are not perpendicular. Let's say that this A is vector B, not A. Let's call this vector B. Okay, let's scratch it. And then let's call it vector B. So this vector B is going to be smaller, since I've drawn it smaller. So the magnitude of this vector B, let's just say, is going to be 40 Newton. Then let's just say the angle here is going to be 28 degrees. Okay. Now the question should normally go like, find the resultant vector. So that's what normally they would say, like, find the resultant vector, right? So that's how the question could be posed. Sometimes you find them say that find the sum. They will say find the sum of vectors, maybe you say vectors A and B. Remember, when I put the arrow, I'm saying vectors. These are vectors. So they could say it like this. So whether they say to you find the resultant, or they say to you find vectors A, sum of vectors A and B, what they mean is they basically want you to find a vector R. Let's call the vector that they are looking for R, such that R, it is actually equals to A plus B. So we have sort of covered how we can actually find this, right? And how we can actually resolve this. So otherwise, you can check the previous video. Now, one thing that you'll notice is that since this vector A is at an angle, it means that we can resolve it into components. We can find an x component of this vector. So you draw a vector. Remember, I said you start from the tail of the vector that you want to find the x and the y. Draw a line horizontally, that's the x component. Draw a line vertically to meet the head y component. So this is A, Y. These are vectors. This is vector A, X. All right. Now, the second vector, which is this one, again, you start at the tail of B. You go this way. And then this is the X component. And then the Y component will be here. So this is BY. And then this is BX. Somewhere here. All right. So already I can say that both of these actually have components, and we have gone through how to actually find the magnitude of the x component, how to find the magnitude of the y component, how to find the magnitude of the x, how to find the magnitude of the y. I've shown you how you can actually do that in the previous video. So we are just going to be applying this in this section. So, and that's all. Once you master this, you can actually answer almost any question when it comes to vectors. All right? Okay. So let's just go up, and I'll try and actually have the sketch showing. Maybe try and reduce it a bit. Okay. All right. So that's fine. Now, if you look at this, now remember what we said. We said that the vector A, if it has an x and a y component, then the vector A is the sum of ax plus ay. And vector B is the sum of bx plus by. So that's what we are going to do here. We are going to say this is going to be equals to, where we see a, we're going to substitute this thing here, which is ax and ay. So we're saying vector a is the same as vector ax plus vector ay. Then vector, this plus is this plus. Then you open the bracket. What is vector b? Vector b is the same as bx plus by. Okay, so that's good. And then what do we do now? Now we break them down. We can group them or we can break them down. It's up to you. So the easiest thing is just to group them. Take all the x's and put them one side. So let's just say ax plus bx, you put them one side, right? So you put them as a group. You can put a bracket if you want to just make sure that you're separating. You are adding, and then you say this is going to be ay. So you're putting all the y's together, and then you're putting all the x's together, right? It's more like you're grouping them. All right, so this is good. And now let's look at the vectors now. Now we are going to break them down. Now the question is, do I know the magnitude of ax? I don't know it. I can calculate it, but I don't know it yet. So I haven't calculated it yet. So I'll just say the magnitude is going to be ax. What is the direction of that? Remember what I always said. I always say you are always looking at this direction being positive and this direction being positive. Therefore, it means that this one, since it's facing that way, it is negative. Therefore, it is in the negative x direction. Okay. Then what about this one, bx? Bx is positive. So the magnitude, do you know the magnitude of bx? I don't know the magnitude of bx, so let me just call it bx. Do I know the direction of bx? Definitely, I know it is pointing in the positive direction. Right, this is just this bracket here. So you have solved all the x's. Right, you can put a bracket if you want, just to make sure you keep everything separated. Put the plus again. Now what about by? Ay, sorry, not by. Ay is going up, so it's positive. I don't know the magnitude of ay, so I'll call it ay. It's going up, so it's going in the y direction, positive y direction. Then b is also going up. I don't know the magnitude of by, but it is also going up. So you can see now I'm doing it the mathematical way. I'm just breaking it down for you so that you understand how everything is broken down. All right. Okay, it's fine. I'll show you. I'll show it back to you. Okay. All right. And then now, so what we want now is we actually want to find out what is this ax and what is this bx, what is this by, what is this ay, sorry, and what is this by. Before you do that, you can simplify it and just say this is that plus bx, put everything in bracket, then take out x, so everything is going to be in the x direction. There's a reason why I'm doing it like this. And then this one, it's ay, the magnitude, it's by, the magnitude, and the direction is y. All right. So now I have to find out what is the magnitude of ay, what is the magnitude of bx, what is the magnitude of a, and then ay, sorry, and by, or ax, not, why am I saying y here? So we're saying x here. Everything is x here. Right. So there's two ways you can go about this. I mean, looking at the right angle triangle, you could do it here if you want. You could do it on the side and just say, looking at the x, and then you could say, well, ax, I've shown you how to get this. If you're confused, look at the previous videos. You could say ax is just going to be a cos of 55 degrees. Then you could substitute whatever that is. You could also say that ay is going to be a sine of 55 degrees. And you could put the values and then get the value itself if you want. You could do it like that. And normally that's easy for students to do. Then if you look at b, you could say bx is b cos of 28 degrees. Okay, and then you could say by is b sine of 28 degrees. Okay, so you could actually say this is all of this, and I showed you guys how do I know whether it's going to be cos, how do I know whether it's going to be sine. So I did show you all of those in the previous two videos. So if you go just to the previous two videos where I'm showing you how to add vectors that are perpendicular to each other, if you look at this, these two vectors are perpendicular to each other and they are giving you A. So I did show you this, and B is also perpendicular to each other and they are giving you B. All right, so that is good. And then so from there, so what I normally prefer to do is just to substitute everything in one, right? So I'm going to continue with that. So what I'm going to do is I'm just going to say this is going to be equals to, I'm going to have an x, and then when I see ax, I'm going to put a cos of 55 degrees. Where I see y, I'm going to put, so where I see bx, I'm going to put b cos of 28 degrees. Close the bracket. This is going to be the x direction. Then this is going to be a sine of 55 degrees, and then plus b, which is going to be b sine of 28 degrees. All of this is going to be in the y direction. Okay, all right, so that's fine. Then you can substitute the numbers now. Now you can just substitute it once, and then you just calculate one thing. So this becomes minus, and I think we said that the other one is 65 and the other one is 40. So let's just go and see what is what. The other one is 45, and then the other one is 40, not 65. So that's fine. We'll keep the numbers as they are. It's 45 and 40. All right. So the first one, A, we said is 45, cos of 55. So you could do this here. After this step, you could say this is equals to 45 cos 55. Remember where the negative comes from. It comes from this. I just took it out, and then when you take it out, and then goes, well, you just want to factor out x. Then you are left with this negative. And then set b is going to be 40. Let me write my 40 properly. Cos of 28 degrees in the x direction. Then this is going to be plus. It seems like some of it is now no longer appearing, so let's make space. So this is x hat, and then this is plus, a is 45 sine 55 plus 40 sine 28. All of this is in the y direction. Now, and then you just take your calculator, and then what you do in your calculator is you just punch in this bracket first and get the number. Then afterwards you punch in what is in that bracket, and then you get the number. So I'm going to do that now, and then so it becomes minus 45 cos 55. Make sure that your calculator is in degrees. 40 cos 28. Then you punch in that. I'm getting 9.5. So which means that this is going to be 9.5 in the x direction. So the x is this x. So this is just this number. The number is 9.5. And then what is the y? The y is going to be plus. And then, so where I see sine, I'll just put, where I see cos, I'll just put sine. Since I have it on my calculator already, it will save me time. And then I'm getting minus 18. It can't be minus 18. It's because I did not remove this minus. I'm getting 55, all right? So I'm getting 55 here, and then it's in the y direction. It has to be positive because everything is positive here. All right, okay, so that is it. Now, okay, so my vector r is actually 9.5 x 55y. Now, there's three ways they can give you the problem. They can give you the problem like I did, whereby they say they draw it for you, or they can give you vector A and B in terms of this component notation. They can say vector A is something, vector B is something, but then they write it in this case, in this instance. Maybe the next example, I'll just do an example whereby they give you vectors like this. We'll just do a similar example like that, but then they give you vectors like that. Then how do you go about that? All right. But then for this one, this is where we are. And sometimes they can give it to you in a problem statement and say vector A is 45 Newton, and then they tell you that it is 55 degrees north of west, and then vector B is 40 Newton, 28 degrees north of east. So that's how they can actually tell it. They can actually give you the statement. So they can give it to you in 3 ways. So you need to know they are saying the same thing, that just that they are saying it differently. So that's how sometimes we ask problems. We're checking your understanding, and then we want you to understand and comprehend different problems, different scenarios, but you should be able to identify that this is actually, you should be able to simplify it and make it the same problem and see how, okay, it's actually a problem that looks like this. It's called modeling. You should model it the same way. All right. Okay. Now let's see, what is this vector? What does this vector mean? Right, before I find the magnitude, then I find the direction, because they said I must find the resultant, and the resultant is a vector, there's a magnitude, has direction. But let's draw this vector. If I draw my Cartesian plane, right, this vector is 9.5, so maybe 9.5 is somewhere here. Then it's 55. 55 is a very big number, so I'm not drawing up to scale, so this is 55, and then here this is like 9.5, right? So if I was to draw somewhere, it would meet somewhere here. So I can draw a vector. So it turns out that it's a vector like this. This is what the resultant vector looks like. Right? Then my theta is going to be this one here. That's the direction of that vector. Okay? So I already know that my vector is going to be north of east, because in order to get this vector, I have to go east, then north. That's how I got the vector. I mean, if you want to find out how to get to the head, from the tail to the head, going the horizontal and vertical way, so what you will do is you first go, so what you will do is you just go east first, and then you go north. So already it's telling you, so you know already that, okay, so it's going to be, whatever direction I find is going to be north of east. Okay, so what is the magnitude of this vector? Now, when it's like this, I've shown you before, just take the square root of whatever is here on the x, which is 9.5 squared. Whatever is here on the y, it doesn't matter whether it's negative or positive, just put a positive number, because even if you put a negative number, it's going to be positive. So the magnitude of this r is going to be, so you see, you see here I have an arrow, so I'm saying this is a vector. Here I don't have an arrow, I'm saying this is a magnitude. All right, some people are going to say the magnitude of r. So some people write it like this, right? So they are saying the same thing. So this is the magnitude of r. This is me saying the magnitude of r. This is also the magnitude of r. Generally, all of us will write vectors like this. You have to put something on top to show that it's a vector. All right, so this is 9.5 squared plus 55 squared, and it turns out it is 56 Newton. Right, remember that it was in Newton, so we're finding 66 Newton. How about the direction? Then I'm going to say 10 of theta. Again, even if you had negative numbers here, don't include the negatives. It doesn't matter. Even if you had the negative numbers, it doesn't matter. It will not do anything, even if you had the negative numbers. So just put the positive number. So we want to say whatever is on the y. Remember that it's going to be 10 of theta. Whatever is on the y, what is on the y? Well, on the y is 55. What is on the x? On the x is 9.5. So this angle is going to be big. Then which means that theta is going to be equals to, on your calculator, you're going to have it, it's going to look like this on your calculator. 55 over 9.5. Right, I go again. If you are confused, what are we doing? Why are we doing this? Go and watch the previous 2 videos before this one. Right? I think it's video number 10, video number 11, video number 11, video number 10. They are going to show you. You're going to have an understanding. What am I doing? So I'm not teaching you that now because I've taught you. So now I'm just applying everything. Right? So if you get confused, watch the previous 2 videos. All right. So It turns out that theta is going to be, it has to be a very big number. I can tell you that much. And yes, it is 80 degrees, right? Is it 80 exactly? Yeah, it seems like it's 80 exactly, right? So theta is 80 degrees. So how do you write the final answer? Then you say R is 56 Newton, 80 degrees north of east. Could write east and north in full, or you could just say north of east. Everyone who has done some physics should be able to understand what you are saying, unless your lecturer is very strict about certain things, wants you to write everything, then write everything, right? But then some of us are very lenient. Like for instance, I'm lenient with my student. I'm very lenient with my students. I don't demand them to adhere to, like, right north, right east. I don't do that. So if they just tell me north of east, I'm okay. I'm fine with that, right? I think if you are at this level, like university, I mean, I'm okay. I'm not too fussed about all of those things. But then lecturers are different, so make sure that you adhere to what your lecturer is actually saying. All right. Okay. Now let's do a similar thing whereby we are going to find R. But now I am going to give to you the vectors in a different notation. So remember, there I draw them for you. So what happens if I don't draw them for you? Right? And I just give it to you in terms of the X and the Y. All right? So I'm going to say I'm going to find R, but R is given in a component way. Okay? So let's use this. Now I'm still saying to you, find the resultant vector. Right? Of vectors A and vectors B. And then I'll say where A is equals to, let's just say, minus 4x plus 6y, and then B is equals to hx, not y, x. And I'm forgetting the heads now. I'm using unit vectors. Plus 3y. So I want you to find the resultant vector. Now this one is a bit, it's a bit friendly because we don't have to start and use cos and sine and everything. It's almost towards the last step. So you don't expect such a question to be a lot of marks. I mean, if your question is phrased the way I did it first, it can be like a lot of marks. But then if it's like this, because most of the work has been done for you, it wouldn't be a lot of marks. I mean, the only thing that you have to do here is you have to say, well, R is going to be vector A plus vector B. And then what is vector A? It's minus 4x hat, 6y hat. That's what vector A is. What is vector B? Vector B is 8x, 3y hat. Group all the x's. It's minus 4x plus 8x, right? Group all the y's. It's plus 6y plus 3y. And voila, just like that, you end up with 4x plus 3y. So you see that now your R is exactly, now you have your R vector looking similar to something that we had here on top here. You see, we ended up with vector R looking like this, but then it took us some time to get the vector to look like this, right? So once your vector is like this, to get the magnitude is very easy, to get the direction is very easy, but then it's fine. I'll do everything again so that you get to practice as well and see how to proceed from here. Basically, I'll be repeating the same thing. Let's draw these vectors. So if we are to draw these vectors, there it is. So I'm told that it's going to be 4x, there's 4. Then it's going to be, it can't be 3y, it has to be 9 here. 6 plus 3 is going to be 9. Right? 6 plus 3 is going to be 9. So therefore, somewhere here it's going to be 9. So I'll have a vector that looks like that, and that vector will be r. And then this will be my theta. Of course, I'm not drawing them to scale, right? So basically, if you want to know how to draw them, you just draw a vertical line here. You draw a horizontal line here. Where they meet, that's where your head is going to be. Your tail is going to be in the origin. That's theta. So if I want the magnitude of r, now I'm going to do it like this, so that I just try and sensitize you guys to different notations, right? So what is the x? Is 4. 4 squared plus 9 squared. And then what is r? Okay, so r is going to come out as the square root of 4 squared plus 9 squared, and that is 9.8. So it's going up. It's going to come out as 9.8. Well, I don't know what it is. They just gave me those things. Sometimes they can say meters. Sometimes they can say anything. Actually, let's make it meters. Sorry about that. Let's make it meters. So they could say this, give it to you like this, and then they say meters. This meters. So which means that the units of this vector that they are giving you is meters, right? And then so which means that this is going to be 9.8 meters. All right. So that's the magnitude. If I want the angle, I'll just say 10 of theta. Whatever is on the y, take whatever is on the y, whatever is on the x, whatever is on the x, which means that theta is going to be 10 in your calculator. You're going to have like the inverse of that, right? Or arc10. If you did maths as well, it's called the arc10, right? To get it. Okay, and then this is about 66 degrees. 66 exactly. Alright, can round it off to 66 degrees. Alright. Now, where is it? I mean, it's still also going towards the east, then north, so it's a north of east. So you could say that r is 9.8 meters, 66 degrees north of east. So it's the same thing. Now, another way that sometimes we can ask you the same thing, we're asking you the same thing, but now we are asking it in a different way, is we could say to you, for the same thing, and then I say to you, find the sum of the, let me just say the following vectors. All right. Now, and then I say to you, vector A is, then I say to you maybe -4, and then 9, and meters, and then I say B is 8, 4, it's meters. So now what is this now? So what they are doing here is, this is the x value, this is the y value, this is the x value, this is the y value. All right, that's basically what they are doing. They're using this coordinate system. All right. So what you now have to do in that is just write this vector in a way that you know how to do it. Right. I'm not going to solve this problem because I've shown you how to solve it once it gets there. So you can refer to that. So this is going to be, you can write this as vector A is going to be -4. This is the x, so it's in the x direction. Plus, because there's a plus, this one is positive, so you put a plus. If there was a negative here, you put a minus here. And then this is 9y. That's vector A. Vector B is going to be 8x plus 4y. So which means that vector R, the sum, which is the resultant vector, is going to be A plus B. And when you do that, it's just going to be minus 4x plus 9y. Put everything into brackets. I don't know why it keeps doing that. Then this is plus 8x plus 4y hat. Alright. Then of course you can simplify this further, and then once it gets to that step, it's easy for you to do it, right? I'm not gonna skip it. I can do it by head, but I don't want to do that. Just to show you so that you get used to it. Right? Group the x's, group the y's. When you do that, you just find that this is going to be 4x plus, I think this is going to be 13y. So once it's here, it's easy. You can just find the magnitude of this. You can find the direction of this. Alright? Now this is going to be very important. You'll see we'll solve some problems in momentum when we are doing momentum. We are going to solve problems when we are doing, as we keep going and we keep doing different chapters, this is going to come back. So you need to be very much aware of when this come back, when it has reduced to this, and now this vector looks like this, what you should do. Alright, so once it's here, it's very easy. You just go back to the steps that I did above, and then you will actually find what you can do with this. Alright, I think for this problem, this should be enough. So in the next video, what I will do is I will do the subtraction of these vectors. Like, how do you subtract vectors that are not in the same line? How do you subtract vectors that are not perpendicular to each other? Actually, I'll do the perpendicular case, and then I'll do the non-perpendicular case. So two vectors you are subtracting in different positions, and maybe I'll also do how you can find a resultant of like 3 vectors, for instance. You could find it's the same thing, you just extend it, but then you can find it for whatever number of vectors. So I think for this video, this is fine, this is enough. You can just go through it, and then yeah, alright, I'll see you guys in the next video. Cheers.